Okay, now we're going to be talking about exponential equations. You can have exponential growth or exponential decay. Normally, you're going to know because there will be words that indicate that something's getting larger, bigger, or something that's decreasing. So, for example, when you earn a raise each year, that's going to be a growth. When something depreciates, that's going to be a decay. So here's a good rule of thumb, or good thing to know. Exponential growth graphs look like this. Exponential decay graphs look like this. And I'll show you on the graph a little bit later. But on these types, here is a general formula to follow. So normally is like if you're investing money, it would be account balance equals the principal 1 plus the interest rate divided by the number of times that that you're applying that, and then to the number of times for the number of years. Uh, and that's the general formula. For this one, it's a raise. So in this case, it's going to be new salary is equal to the salary given 1 plus the interest rate over, you're only going to get a raise once a year, so that n will equal 1, but it's still over n, and then the n is still 1 times after 6 years. So in this case, the original salary, or the beginning salary is $57,600. 1 plus a 3% raise, so 0.03, excuse me, divided by 1, because they're getting a raise once a year. And we're going to raise that to the once a year times the number of years. Okay? So 1 plus 1.003 is just 1.03. And then 1 times 6 is 6. And you put it in the calculator just like that. If you want to try to do it by hand, have at it. But 57,600, parentheses, 1.03, parentheses, the caret button, and then parentheses, 6, well, in this case, I guess it's just to the 6th power. And what you're going to have left, that new salary, will be $68,777.41 yearly. Okay, so that's that process. A car's depreciation is the same thing, so the new value is equal to the original. So you bought it for $32,100. And it's depreciating at 6% per year, so that the n is 1. And then so that's 1 times, and then 5 years old. So you just plug all that in. 32,100. 1 plus 0.6 is 1.06. Raised to the 5th power, because 1 times 5 is 5. Oh, hold on a second. So key thing, when it depreciates, the reason why I caught my error is because the value of the car went up. No. When it's depreciates, that's a subtract sign right there. So this becomes 32,100 times 0.94 raised to the 5th power. Almost. That's not good. So now what you should have is 23,558 point, and it rounds to 32 cents. In the real world, probably not going to happen unless you have a very, I don't know, something very unique or special about your car. It's typically going to be lower than that. But that's just an example of how to set it up. Here's the savings account ones. So a saving account balance is compounded annually. So account is principal times 1 plus interest rate over the number of times it compounds, raised to the number of times it compounds times the number of years. So the principal is $1,393. 1 plus 0.02. The n is 1. That's raised. The 1 times 8. 8 is the number of years. So the new account balance, it's not going to go up a lot because it's only 2%. But $1,393 times 1 plus 0.02 is 1.02 raised to the 8th power. So you'll make some money, it just won't be very much. So that's about, since we're rounding to the hundredths place. Yeah, and if they want to know how much interest you earned, it would be the new value, subtract the original value, and that would be the interest amount. All right, let's look at this one. All right, so this is going to act as principal. This is the rate. This is the time, and the same thing's going to apply. So instead of account balance, it'll be how much the new fund will be. It started off with 523,000, and this is annually, so the N is 1. 11%. Wow, that's going to grow quite a bit. And after 9 years, this should grow quite a bit. So you type that in, 523,000. I'll make sure that I'm reading that right. Parentheses 1.11, since this is divided by 1, it'll just be 1 plus 0.11 raised to the 1 times 9, so that'll be 9. So what we have is, looks like $1,337,853.31. Nice. All right, let's do. I'll stop this video and then I'll do some other videos on growth and decay.